So welcome to day 2 of the Solana Blockchain Developer Bootcamp. Yesterday you got your first taste of what it's like to be a Solana developer. We learned all about Solana, we learned about the programming model, we learned about what accounts are, what programs are, what serialization and deserialization is. Right? We played around, deployed and interacted with Solana smart contracts. So today we're going to continue by focusing on this thing called the Anchor framework, and then we're going to talk about oracles and Chainlink data feeds. Right, so it's going to be awesome. There's going to be even more exercises to play around with today. So yes, Solana is definitely chewing glass, Jay. So once again, my name is Harry Papakarisiou. I'm a developer advocate for Chainlink Labs. I'm joined today by Zach as well from the Chainlink Labs DevRel team, and he's going to be helping us out again. So if you want to add me on socials, look me up on LinkedIn, Twitter, and there's my email address. So today's outline, like I said, is we're going to focus purely on introducing the Anchor framework and talking about it. And then we're going to talk about how you can use Chainlink data feeds on Solana to get high quality price data in your Solana programs. So once again, it's going to be a 3-hour session broken up into sections. We'll try and get 1 or 2 breaks in there as well. It'll be some presenting followed by some questions. I'll demo some exercises and then you guys can do some exercises as well. And if you have any questions after the session today, you can ask them in the in the Bootcamp channel in the Chainlink Discord. I need to update that slide. So the requirements for day 2 exercises are exactly the same as day 1, except we're also going to be installing the Anchor framework. And in terms of what we're going to be talking about today, like I said, we're purely going to be talking about Anchor. We're going to do 2 exercises that use the Anchor framework. Then we're going to introduce the Oracle problem and Chainlink, and then we'll build our last exercise that uses Chainlink to consume price data on a Solana program. So let's start by talking about Anchor. So I'm just going to turn my video off now because we're going to be looking at some code. And if everyone can full screen and minimize or get rid of my avatar, it'd be better that you can see the presentation screen as big as possible. So in the Web 2 world, you have things such as Rails, right? And in the Ethereum world, you have things like Hardhat, Truffle, and Web3.js. And what these basically are is they're tools designed to increase developer productivity, right? And they do that by abstracting away some of the more low-level details of the underlying platform, right? So they kind of increase your productivity. So in Solana, we have what's called Anchor, right? So Anchor is a Solana framework built by this protocol called Project Serum, which is a decentralized exchange and DeFi ecosystem built on Solana. If you haven't heard of them, you'll definitely come across them when you start looking at Solana more. So I posted the link to Project Serum in the chat. So these guys basically built Project Anchor because they saw a need. They saw a need to basically be able to develop on Solana a bit quicker and easier than using the raw Solana kind of programming model that we went through yesterday. Whoops, I lost myself. So Anchor is basically a framework for building Solana programs, right? And it reduces coding effort by generating various bits of boilerplate code so that you don't have to do as much of the things we were doing yesterday in terms of things like serialization and deserialization and things like that, right? So Anchor can kind of simplify that process for you and give you more time to focus on, building the logic of your smart contract. So I think the majority of the top 10 protocols by TVL on Solana use Anchor. So it's becoming quite clear that it's kind of like almost becoming a standard that people use to build things on Solana now, right? So if you're working on smart contracts on Solana, a lot of people use it because it allows them to kind of iterate a lot quicker in their development. So in terms of the things that Anchor provides and uses when you build smart contracts on Solana with Anchor, we have the Rust smart contracts which we went through yesterday as well. We have this thing called an IDL file, right? And we have this, we build clients as well, similar to how we built clients yesterday, except we build clients using the Anchor JavaScript library. And we have a CLI as well. So we have an Anchor command line interface that we can use to build and deploy Solana smart contracts that use Anchor. So here's the workflow when using Anchor on Solana. I saw a question in the chat. Is Anchor the equivalent of Brownie for Solidity? It's kind of like a hard hat or Brownie, but it's not. It's got a couple of features that hard hat and Brownie or ethers.js uses, but it's not its own complete development framework, if that makes sense. But as I go through it, you'll understand more, right? So here's the workflow here. So you have your smart contracts written in Rust, just like we did yesterday, right? And from those smart contracts, you build them with Anchor, which not only compiles a Rust program into bytecode, just like yesterday, but it also generates this thing called an IDL file, an interface description language file, right? And from that IDL file, we can then generate clients, with JavaScript, TypeScript, whatever. And then with these clients, we can then talk to our smart contracts and test them, right? So, if you're coming from the EVM mental model, some of these things will be similar and some of these things will be a little bit different. But as we get more into Anchor, you understand that it kind of makes developing on Solana, especially on the client side, very similar to using something such as ethers.js or web3.js for Solidity. So at a high level, Anchor program consists of three parts, right? We have the program module, where the program logic is written. We have these things called account structs, where accounts are validated and where we say for each function call or instruction, what kind of accounts are we expecting to be passed in. And we have this thing at the top called the declare ID macro, which stores the address of the program, right? So in the Solidity world, we can kind of get the address. You can get the address of a deployed program from within that actual program. With Solidity, with Solana, we have to basically store it. So we'll go through that again in a minute, if that doesn't make sense. So here's an example of a very simple Solana program written that uses Anchor, and at the top we say we're using the Anchor library here. And basically all these parts in red are like little hooks or macros or whatever you want to call them that you put into your program that Anchor then uses when you build and when you build your smart contract. So here's a declare ID thing that I talked about before. This basically says this is the ID of this deployed program. Then we have the program section that defines all the logic of the program. So we put this little program hook or macro here. And then down here, we have all of the accounts, right? So all of the incoming accounts here, right? And if none of this makes sense, don't worry. We're going to go through a few examples and I'll literally walk through line by line and explain it. So this little, this account section at the bottom here, this is where you define which accounts your instruction or function expects and what constraints these accounts should follow, right? So basically this account type is used when an instruction is interested in the deserialized data of an account. So what that basically means is, let me just go through this example here. So we have this thing called my account here. So this is basically a struct that we've defined, and we've put in these little anchor hooks here to say this is an account. So this is basically saying we're going to be storing data and retrieving data and doing things with something of this type here, right? So that just defines the structure, and it just has one element in it. It's data and it's a unsigned integer U64, right? So basically, one thing to note as well is when we specify account here, it actually sets the owner of this data to the ID in this declare ID section above. So this declare ID will always say this is the ID of the deployed program, right? By doing this, we're actually saying that this program here owns this data here, right? So the account type can then check for you that account info passed into your instruction has its owner field set to the correct program, right? Now, in addition to this, we have the program logic declared here, and then we have the accounts section set here. And we'll go through that one next, I think. Oh, let me just go back. Yeah, so, hold on, where was I? Yep, here. So in addition to this, we have this thing that's called a context, right? So for every anchor function or every function you use that you want to use anchor for, basically, as you can see, you have a function here called set data. You always pass in this thing called context, right? And then in brackets here, you then specify context. And whatever you specify here needs to match something in this accounts struct here. So what this basically means is when this function is called, here are all of the accounts. Here are all of the accounts that we're expecting for this function call, right? And basically by doing that, you don't have to do any parsing of accounts and deserializing data or anything. It will do it all for you. And we're going to go through an example of that in a minute. So you can also have constraints when you define these accounts down here, because accounts aren't dynamic enough to handle security checks, or certain security checks anyway. So you can do things like when you declare accounts, you can say, you know, my account.mint should equal, you know, something else.mint, right? So just basic logic you can kind of have there as well. Now the program module. So this little program hook that we put in, this is where the business logic is defined, right? And we can basically write functions which can then be called by clients or other programs, right? And like I said before, each defined endpoint takes a thing called a context as an argument, and this basically provides access to the accounts of the executing program and the program ID. So this says what accounts are we expecting when this function call is made. Now, in addition to this, I don't know if you guys realize, but there's actually another parameter in this function here called data, and it's a U64, right? And we can actually add instruction data to functions after the context argument, and Anchor will automatically deserialize the instruction data into the arguments. So in yesterday's examples, we literally had to take our input parameters in our client, serialize them into a byte stream, send them in the instruction data, get them from the instruction data parameter on our Rust program, deserialize it into its original state, and then play around with it. Over here, it's literally like Solidity, where you can have normal function parameters in the function definition, right? So something that's, you know, normal in almost every other programming language. With Anchor, you can actually have them in here, and Anchor will take that, and because you've specified a context here, it will automatically know what it needs to deserialize that into, and it will automatically deserialize it, and you can start using it without having to do anything, basically. So here's an example of that here. So we have this, here's the program definition. We have this little program hook here to specify that. So we have a set data function, right? And once again, we have to specify a context always. And we're saying context set data. That means it's going to come down here and it's going to look for an account. Wait a minute, I'm missing a bit there. It's going to look for a set data context, and it's basically taking a parameter called var, which is a unsigned integer 64. And I wonder if I can get it if I go back 1 minute. Yeah, here. it's taking a parameter U64, and because the context is set data, Anchor is going to come down to the derive accounts hook here and look for a struct called set data. And it's going to find it, and it's going to say, okay, we're expecting this one account being passed in, and we're going to call it my account, and it's of a type my account here. So it's going to go there, and then it's going to look for one of these in an account tag, right? And it's going to find it and go, okay, so this account has a type data U64, right? So that's kind of how you can just automatically pass in parameters, and as long as you've got the context all set up and the account tags and things like that, Anchor will automatically do the deserializing for you. So we'll talk about the IDL file next. So when you compile a Solana program using Anchor, it does the normal compilation just like we did yesterday, and then it also generates an IDL specification for programs. So an IDL file is, if you're coming from the EVM world, an IDL file is kind of similar to an ABI file, and it's used by clients to interact with a deployed Anchor-based program, right? So we'll take a look at an example of an IDL file here. So first of all, let's start with this initialize instruction here. You can notice that it's got a data parameter passed into the program, right? So this argument and any other Rust types can be passed into the instruction to define the inputs. And as you can see, we're taking a mutable reference here to my account, and we're assigning the data here to basically this data here, right? And basically what that does is, because we've specified the context as initialize, it's going to come down here and it's going to say, okay, these are the accounts we're expecting to be passed in for this function call. We're expecting a my account. We're going to call it my account. It's an account of type my account, which is this type here. And as you can see here, the my account field is of type account info my account, right? And the deserialized data structure is my account here, right? So, and as you can see on top of this, it's been marked with this little init attribute here. So basically this means that it's going to create a new account owned by the current program, and it's going to be zero initialized, right? So when you specify init, you also have to provide a payer. So in this case, we're saying payer equals the user, and it's going to fund the account creation. It's going to assign the specified space that we say in the space tag here. And in this case, we're saying 8 plus 8, 16. So all accounts created with Anchor are laid out with an 8-byte discriminator, and then just whatever data you want to store after. So that's why we did 8 plus 8. So in yesterday's exercises, we were creating accounts with the JSON RPC API by doing what's that function called? Is it create account or something? So we're having to create them from the client. We're having to do the call to create the account, allocate the space, pay the rent, etc. And then once it was created, we were then calling our function. With Anchor, if you just set up your accounts like this, if you want to just create one, you can just do it from within your program like this, right? So here's an example of the generated IDL file for this program. So you can see we have our initialize instruction here, right? These are all the accounts that it expects: my account, user, and system program. It matches the context struct here: my account, user, system program. And then here's the arguments: data, it's of type U64, matches that. So yeah, it as you can see, it kind of gives you like a Solidity ABI kind of vibe. So now that we've got a program compiled and we've got an IDL file, let's see how we can generate a client, right? So yesterday when we did some stuff in TypeScript, as you saw, especially for the second one, we ended up having these massive files because we had to create classes and we had to do serializing and deserializing and all those types of things, and it ended up, creating quite a bit of code. You can see when you generate clients using Anchor, so Anchor's got its own Anchor JavaScript library for interacting with Anchor built programs, you can literally interact with your deployed programs with a few lines of code, right? So as you can see here, we're literally reading in the generated IDL file first, and then we're using the Anchor JavaScript library. We're going program ID equals new Anchor Web3 public key, and then you pass in your deployed program ID. And with those two things, you can literally go new anchor.program, pass in the IDL and program ID, and it gets a connection to your deployed program to interact with. So very similar to ethers.js, web3.js, where you kind of get a connection or get a reference to a deployed smart contract to interact with it. And once you've done that, you can then basically just interact with your program. So in our case, we're generating a new key pair for our account that we're going to pass in, because remember our function call takes in this my account here. So we're just generating a key pair. We haven't created the account yet. We're just generating the key pair. And then instead of generating a new transaction instruction, populating the instruction data with a serialized byte array, and all those types of things we were doing yesterday, we can literally go program.rpc. So program was this thing that we created here, .rpc dot function name, right? So our function name was initialize. So .initialize, and then the context automatically gets set. And then in our initialize function, we had a data parameter here, right? And so right over here, we're just saying it's a new big number. I'm setting it to 1, 2, 3, 4, right? So we're literally calling a function with JavaScript .function name, and then in brackets passing parameters, which is like completely different to what we did yesterday. A whole lot easier, more like Solidity and things like that, where you don't have to do serializing, deserializing, you don't have to generate transaction instructions and things like that. And then all we have to do is specify the accounts that are being sent in an accounts object here. So my account is this one that we created there, and then the user in the system program. It matches what's expected in the initialize struct here. And then that's it. It'll call the function for us. It'll pass in the parameters. Anchor will automatically look up this context, initialize. It will automatically deserialize this my account thing for us. And then we'll have access to the data, the my account data and everything. So a whole lot easier, a whole lot less code. It's just kind of adding some of these hooks in to your program to specify here's where the program's logic is, here's the program ID, here's the context for this function call here are the accounts that we're expecting for this function call, and for this account here that we're going to be storing stuff in, here's the structure of the data, and then Anchor just does the rest for you, right? So now that we've got the client, this is how you kind of wrap everything up and get it working. So instead of compiling programs with the commands that we were using yesterday with the Solana CLI, we're going to use the Anchor CLI. So we're going to do Anchor build, and it's going to do the normal compilation just like we did yesterday. However, it's also going to generate the IDL file for us as well. And then to deploy, we use the Anchor deploy command. So it will deploy all programs in the workspace to the configured cluster, and you can optionally specify a cluster on the command line there as well. So if you want to build or start a new project that uses Anchor, you can go Anchor new and then type in a program name, and it will initialize a new project workspace with all the structure required basically. And in addition to this, you can also use Anchor init, which will create a new program in the workspace, initialized with boilerplate code, as opposed to new, which will just give you the directories and the config files. And also you can use Anchor verify to verify our on-chain bytecode with compiled artifacts. And you can also do tests with Anchor. So there's a test folder when you do a new Anchor project. If you do Anchor test, it will run the integration test suite. It will basically look for test script files that are defined in the anchor.toml file. Cool, so we're up to our first exercise. Once again, if you guys can just stay with me and let me go through it, it should take me about 5 minutes. And then we'll leave you guys to have a bit of a play. So I just pasted the day 2 exercises, right? So you're going to need to install Anchor here as well. So you can check if it's installed already, if you've done some playing around in the past, by going anchor-version. So I'm running on version 0.20.1. In the instructions, I specifically state to install 0.20.1 because that's how the doc was written for, and it's the most stable. But there's been a newer version since, or two actually, so 0.23, I think. If you do install the latest version, there is some syntax changes that need to happen in these exercises. So make sure you read the exercise doc carefully and don't skip anything, because I'll specifically say in some sections, for example, in this first program here, I'm going to say, if you're using the latest version of Anchor, replace the text program result in the execute function, which is here, with the text result. So just a difference in syntax from the versions. So if everyone can just, once you've installed Anchor, just check if you've got 0.20 or 0.23 and just take note of whether you need to do some of those changes. So once Anchor's installed, we're going to initialize a new project with Anchor, and we're going to call it GM Anchor. Now, in terms of what we're doing for this exercise, I thought it'd be cool to recreate the GM program that we did yesterday in the first exercise, but this time to do it with Anchor. So you can kind of get a good feel for what the differences are, and you can look at both repositories after and go, oh yeah, in day 1 we did it like this, and then in day 2 we did it like this. So functionally, the result is exactly the same in the end, but under the hood, it's going to be different. So this version is going to use Anchor, but it's going to be deploying a program. We're going to say GM, it's going to get passed in, a name's going to get passed in, that name will get stored in an account, right? So once that's done, we're going to install the minimist npm module to take some parameters on the command line in our client. If you've got your local validator still running from yesterday, you probably don't need to run the steps to start it or to set it, but I have my local validator running still, so I'm not going to start it again. If you couldn't get your local validator running yesterday, you can do these exercises using the DevNet environment, public network too. So just follow the steps in the exercises just like yesterday to run it on DevNet. Now I'm going to generate, using the Solana keygen command, I'm going to generate a new wallet address for myself, specific for this project. And I'm going to use the airdrop command on the Solana CLI to get myself some tokens. So I'll get 2, I'll get 4, that should be plenty. Now, when you're running clients that use Anchor, there's no way for Anchor to basically look into the Anchor config. So there's an anchor.toml file here that has a bunch of config. But when you run a program from JavaScript to like, interact with your deployed programs, there's no way to kind of hook into that. So there's a couple environment variables that Anchor looks for when you run a client. And one of them is the Anchor wallet. So basically the wallet address that you want to use for signing transactions and stuff. So in our case, we're going to set it to id.json, but we're going to set it to id.json backer folder because we're going to be generating our client in this app directory here. So that's why we did that. So now we're ready to put in our program code. So there's already going to be some boilerplate code in the lib.rs file. We're going to blow it away and put in ours, right? So we have a declare ID, which is our program ID. This is going to change because this is like an old number, an old one. We have a execute function here. It's got a context of execute, and it takes one parameter in this function, and it's a string, and we're calling it name. So the context here is execute. So if we go down to our derive accounts section, you can see we've defined an execute struct here. So this basically says these are the accounts that we're expecting to be passed in for this execute function. So the first one is we're expecting this thing called GM account to be passed in. It's an account and it's of type greeting account, right? So then down here in account, in this account tag, we've defined a greeting account struct that has one thing in it called name, and it's a string, right? And for this account here, because we've specified here that it's init, it's going to be basically created, right? The person paying for it is going to be the user, which is this second account here that's passed in, and we're allocating 32 plus 8 bytes of space, right? Andre, I just saw your question. I'm going to answer it in 30 seconds. So the next one is just the user, our wallet address that's signing the transaction. And then you need to, anytime you use Anchor to kind of create a new account, you need to pass in the system program as well, the system program ID. So these are the accounts for that context. This is the structure of the first account. And then all we're doing, we're not doing any deserializing of instruction data or anything. We can instantly just hook into this name and use it, and we can instantly just use this GM account account here. So we just say let GM account equals mutable reference. So you go context dot accounts, right? Dot, and then whichever account you want to use here. So in this case, it's GM account. So we can literally hook into it like that, and it will automatically, we won't have to do any deserializing or anything. And then we can just say GM account dot name, because remember this is of type greeting account, dot name equals, and then this name here, right? And then that's it. We don't have to do any serializing of data again. We don't have to do any saving or anything. We literally, in 2 lines of code, we literally took in a string parameter from a client and then stored it in an account, right? So as you can see, quite a lot easier. Now, let me explain this declare ID thing. So Andre asked a great question in the chat. The program ID can be any string, how to define it before deploying the program. So Anchor's got this weird thing where you need this declare ID to say what the program ID is, but you can't actually know what it's going to be until you build your program for the first time. So when you build it for the first time, that's when it gets assigned a program ID. And then every time you rebuild it after that, it's always going to be the same ID unless you blow away your target directory here, and then it will build it again from scratch. So, but the problem is because you don't know until you build it, you need to build it first, then you need to extract it from the generated metadata, and then you need to then take the program ID that was generated, put it back in here, save the file, and then do an Anchor build again because you've changed the source. So with Anchor, you have to do Anchor build twice, and it's just this thing that everyone just accepts, and they might find a solution for it in the future, but for now, that's what people do. So what I'll do next is I'm going to do an Anchor build on the command line, and it's going to build it, but it's going to build it with this program ID, right, which is wrong. And once that's done, this command here, using the Solana CLI, we can take the generated IDL file, I think it is, and we can actually extract the address or program ID that was assigned when we did that build from that file, or using that file, sorry, we can look it up. So I'll just wait for that to finish. So now that we've done an Anchor build, a program ID has been assigned for when we do a deployment, right? Cool, so that's ready. So now if I go Solana address -k, and then I pass in that generated JSON file, it gives us what the program ID is. So it says, this is the program ID of your Anchor program when you deploy it. This is what it's going to be, right? But now we need to take that, put it back in our program, save it, and then do an Anchor build one more time to build it again. And it should be quicker the second time because everything else is compiled. And now that we've done that, now our program is compiled with the correct program ID that matches the ID when it gets deployed. So that's just, yeah, something that Anchor does, and it's just part of the framework for now. So just a heads up with that. And once that's done, we're ready to deploy. So Anchor deploy will deploy it to our configured cluster, which in my case is the local one. And there we go. And as you see, the program ID in the output here, it matches the one up here, right? So we have a match. So now let's create the client. So we're going to create the client in the generated app folder right here. So I'll go create. So we're going to generate a JavaScript client today using the Anchor library here, Project Serum Anchor. And I specify because I'm using the local cluster here, I'm saying provider.local. However, I'm not sure if I say, if you're using DevNet, and I'll add this to the doc because I don't think it's there, I think you need to change this to env, right? So just a heads up if you're using DevNet. For now, I'll leave it as local, and we're setting the provider to the local cluster. So here's where we're using the minimist JavaScript package to take parameters from the command line, because we're going to specify the name on the command line. So all we're going to do in our main function is we're going to read the generated IDL file. So target IDL, let's take a look at it. Target IDL gmanchor.json. So here's our IDL file. Here's that address that we used, but that we looked up before. So we're going to take that IDL file. We're going to take the program ID from the command line, right? So it gets passed in when we're going to run our client. And we're going to take a name from the command line as well, or it will default to Glassdoor. And then we're going to get a connection to our deployed program using the IDL and the program ID specified, right? So once we have that, we're ready to call our function. So we just need to generate a new key pair for our GM account. This is the account that we want to be created and to store the name that we pass in. And then just like in the slides, we're going to go program.rpc.function name, which is here, execute. And then we're going to pass in our parameter, which is the name, the string, right? And then we have an accounts object to pass in all the accounts that are expected. So the first one is this GM account that we want to create, and we generated a key pair for. And then the user, which is our wallet address, and then the system program. So Anchor has like a static variable that you can use to pass in the system program. And then that's it. It will call that function for us. And then we will print out the transaction logs here. And then after that, we want to then read the value of the account that was created to make sure that the name was stored there. So in yesterday's example, we had to do a get account info call on it using the RPC API, and then we had to deserialize the byte data that was returned, and we had to deserialize it into a JavaScript object and then read that object. So in this case, you don't have to do that. You can literally say program, so this program that we got the connection to, dot account dot greeting account here, right? Dot fetch, right? And then in the fetch, you just need to say what is the public key of the account you want to fetch the data for. So this is saying we want to grab, we're going to be grabbing this type of data. This is what we want to deserialize it to, and we want to get it from this account here. And then once that's done, you can literally say stored program dot, and then in this case, name. So unlike yesterday, we're not doing any deserializing. We don't need to create any classes or schemas in our client. Anchor just does everything for us, right? So in one line, we literally just did the equivalent of yesterday of the get account info, and then the deserializing into an object and then printing the object. So once that's done, whoops. So as I said before, there's a couple, when you use clients with Anchor or generate clients with Anchor, there's a couple environment variables you need to specify so that Anchor knows where to basically run things and look and stuff. And one of them is anchor provider URL, right? So in the anchor.toml file, in the provider section, we have a wallet and a cluster specified here so that when you build things and deploy things, you can kind of use these as default values if you don't specify things on the command line. However, when you're running clients in JavaScript, you can't hook into this. So that's why we create these environment variables. So in my case, I'm setting anchor provider URL to my local validator. And then I'm going to run the client. So I'm going to go cd app, and I'm going to say node client.js, and we're passing in the program ID, which is, we're going to dynamically return that using the Solana CLI, and then we're passing in a name parameter, in my case, of Harry. If I run that, as you can see, it was successful. Here are the program logs, and then in this client where we read the account, we say store GM name is store name.name, and it's got Harry there. So there you have it. It's exactly the same program as we created yesterday. However, this time we created it in Anchor. We specified these hooks in the Anchor program, and then we generated a client using the Anchor JavaScript library to achieve the exact same result as we did yesterday. So I'll leave it now to you guys. Have a bit of a play. I think we've got about half an hour. Let us know if you have any questions, and I'll try and go back and have a look at some of the questions that are outstanding. Thanks. So for now, for those who are able to deploy and successfully interact with their deployed program, awesome work. You've now deployed a program and interacted with it that uses the Anchor framework. So we're pretty much going to go straight into the second exercise. And the second exercise is, it's called Solana Social, but it's very similar to the first one, except the difference is where we're doing two function calls this time, where we're creating something, and then we have a function call to update it as well. So these are kind of like, you can think of them as social media posts, and there's a function to create a post, and then one to update a post as well. So I'm not going to go through step by step because we're running a bit behind schedule. I just want to walk everyone through the code just quickly. So Solana Social programs. So once again, we have our declare ID, and now we have some variables here where we're defining how much space a post actually needs. So as you can see, a post here is comprised of the 8-byte discriminator, plus public key length, a timestamp, and the length of a title and content, right? So we're going to use that when creating an account. So basically this program, we have two functions, create post and update post. So create post will store a post on the chain, or in an account, sorry, and update will then update one. So for the create post, we have a context of create post here, and we take two parameters in, a title and content. So if you go to create post in the context accounts here, you can see that we're expecting an account called post that's coming in. It's of type post here. So as you can see, we have a struct called post that has an author, title, content, and timestamp. We're initializing this account that comes in. The author, which is the next account, is the one paying for it. And then the space, we worked out in that calculation further up how much space we need. And other than that, it's taking in the author, which is the signer of the transaction, and the system program because it's creating a new account. And all create post is doing is it's just setting the values post.author, post.timestamp to the current timestamp according to Solana, and it's storing the title and content from the command line, right? And it's just saving them in that account. So very much similar to what we just did, except there's just like, 3 extra things that are being stored as well. So the update post, which uses the update post context, also takes in a title and content. It does some basic validation on it, and then it just sets the title and content to in the post account. So if you take a look at the context for post, update post, sorry, it's different to the context here because we're not creating anything. We're just retrieving an existing account. So the modifier here, or the little tag, we're saying it's an account, it's a mutable account, and we're actually doing a check that basically says the signer of this transaction should be the author, which is passed in as well as the next account. I think has one basically just means signer. So it just takes those two accounts in and it just sets the values. So it just updates the values. And then on the client side, once again, it's very similar to what we just did. We're using Minimus to take a bunch of stuff on the command line, the program ID, the action we want to take, create or update, the title and the content that we want to use. And when we're doing an update post, we need to get the account ID or the account address of the post that we want to update. So very similar to how we did it before, we get a connection to the deployed program. In the action, in the create action, we're calling the create post, passing in the title and content. We're passing in a new account that we're generating a key pair for. We're passing in wallet address as the author. And then once that's done, that will get created. And then for update, we're taking in the, from the command line, we're taking in the post account, the account address that we want to update. And that's being sent as the first account called post. Once again, that's what we're expecting in the update post context here. And the author's the signer. And we're passing in the title and content that we want to update things to. So I'll just quickly try and run that. Whoops. So I'm running this on my local network again, and when we run our client for it, I'm specifying the program. I'm getting it programmatically using the Solana CLI. Action is create. So we're going to create a post. The title, this is the title. The content is, this is the content. So if I run that, you can see it's successful, and we read the data from the account. This is the title, this is the content. So now I'm going to run the update post command to update the post, but in the command line call, we need to pass in as a post parameter the wallet, the public key of the account that was created previously. So that's this post account public key. This is the account that we want to update that had our post. Run that, and now it says, when we read the account, it now says, this is a new title, I've updated the contents. So we're not introducing any new concepts in this exercise. It's just purely getting used to using Anchor again, getting used to putting in these hooks in your program, doing the Anchor build twice to get your program ID, specifying where your program logic is, creating functions that have contexts, setting the context in with structs to say what kind of accounts are we expecting and what type of those accounts, and yeah, just getting you familiar with Anchor. So I'll leave you guys for a good 40 to 45 minutes, and then we'll start talking about Chainlink after that. So I'll try and go back and help some people that are having issues as well. And I also suggest, if you have got technical issues, you can also join Zach's Google Meet session, which I'll paste here in the chat again. All right, for those who are able to successfully complete the first two exercises, awesome work. Hopefully everyone got a bit of an insight into using Anchor. I know there are some people still battling with errors. We've got one more exercise, so don't worry too much. You have a decent amount of time to catch up. But for now, we're going to move on because we had quite a few people that had finished. So let's see what people think of using Anchor now that we've done an example. So I'm going to paste this URL in the chat. And if you guys want to go there, let us know using Anchor to create smart contracts is, let us know what you think. Faster, helpful, doesn't work, frustrating. Hello world. Way easier and readable. Helpful. Time saver. Awesome. It seems like for a lot of you, it makes life a little bit easier. For those that find it still a bit frustrating or hard, don't fret too much. Once you get things working and once you understand just how all the hooks work and things, it definitely makes life a lot easier as a Solana developer, which is why the majority of projects in the space actually use Anchor now. Having said that, Anchor does have, there are certain things that are abstracted away that you don't have control over. So for some people that want the uttermost control over certain things, they may not want to use Anchor, for example. Cool. All right, but for now, let's move on and talk about the Oracle problem and Chainlink. So now that we know why smart contracts, what they are, and kind of we've played around with them on Solana, let's talk about their biggest limitation. So smart contracts are not able to connect to external data or any off-chain resource on their own. So you might ask, why can't a Solana program just make an API call, right? And the answer is that the blockchain is deterministic, and if making an API call is part of your smart contract logic, then there's a chance that nodes can get different results. Some can get timeouts, etc. And in this case, if that happens, then your blockchain is no longer deterministic. The nodes are no longer in 100% in sync with each other, and they won't know how to proceed with the smart contract execution. So this is defined as the smart contract connectivity problem, not being able to connect to external data, systems, and events. So to interact with the outside world, we need what's called an oracle, right? And an oracle is any device that interacts with the off-chain world to provide data or connectivity to smart contracts, right? So they report the result of the data or computation on-chain so that the blockchain can stay deterministic, right? So if you have like a web API returning data to a smart contract, instead of a smart contract reaching out and saying, hey, what's the weather in New York right now? The smart contract reaches out to an oracle and says, hey, I want to know what the weather is in New York via this API. The oracle will do the API call itself. It will get the result and it will send it to the smart contract and say, this is the result of the API call. And then every single node in the blockchain has that as an input to the smart contract execution, so that we keep that determinism and every node is completely in sync, right? So here's where things get interesting though. Using a centralized oracle actually creates a single point of failure for smart contracts and compromises the overall security of your smart contract. Because if you've got this highly secure, decentralized blockchain like Solana, but then you're triggering or looking up data from just a single source or a centralized oracle, then your end-to-end security is quite low, because you have one point of failure that can basically be hacked, manipulated, or gamed. So how do we get around this problem? The answer to this is a decentralized oracle network, right? And that's what Chainlink is. It's a modular decentralized oracle network for getting secure and reliable data on-chain and for triggering external computation, right? So by doing this, we solve the problem by extending the decentralization and trust minimization properties of a blockchain and smart contracts out to the data delivery and data source layer. So to try to wrap your head around this visually, here we have a Chainlink decentralized oracle network here on the left, providing price data to a smart contract in a highly secure, tamper-proof and decentralized manner. Right, so there's multiple data sources here, as we can see by the slightly different prices. There's multiple Chainlink nodes fetching the data from the multiple data sources. Everything's getting aggregated, and then the final report or the final price is then becomes the reference price. This is the price of this asset right now. So by combining on-chain smart contract code or Solana program code with off-chain resources such as oracles, you get what we've defined as a hybrid smart contract, right? So these are actually smart contracts that rely on existing on-chain code, and combine it with critical off-chain computations, right? So you can kind of think of them as like a supercharged version of a normal smart contract. So whenever you hear the term hybrid smart contract, you just need to think it's a smart contract that contains on-chain data and computation, as well as off-chain data and computation. So what are some of the use cases for hybrid smart contracts? Well, DeFi is probably the best example of hybrid smart contracts in use today, right? So for those who don't know, DeFi is taking any financial product or instrument and putting it on-chain, running on a blockchain with smart contracts, right? And this has numerous advantages over traditional financial products and instruments, such as having direct control over your assets, transparency built in, and in the case of lending and borrowing, superior yields. So how does Chainlink help to enable DeFi then? Well, many DeFi protocols need to know the price data. They need to know the price of gold, the price of Bitcoin, the price of the USD against the euro, for example, right? So providing this high quality price data, Chainlink gives DeFi protocols the data they need to operate. So this is what our Chainlink the data feeds do. They provide high quality and decentralized price data to these DeFi protocols, right? So Chainlink powers, I think, the majority of DeFi today. So in terms of the architecture, I explained it a bit before, but basically we have multiple Oracle networks acting as data feeds, and each Oracle network contains a number of Chainlink nodes, and then each node fetches data from multiple data sources, and then the nodes all talk to each other and they come to consensus on an aggregated price for the asset. They use a volume-weighted average price method, and then that is then pushed on chain, and that becomes the current price of the asset at that time. So our price feeds are live on the Solana DevNet network right now, today, and the team is currently finalizing the implementation for the price feeds on mainnet. Right, so they're going to be going on mainnet very, very soon. But for now, these are the price feeds we have available on the Solana DevNet network. So we've got the price of Bitcoin, Ethereum, Chainlink, Solana, and then a couple stable coins, right? So if you go to our docs at docs.chain.link, you can kind of see all the data feeds here too. So the way that the data feeds are implemented, once again, we have a separation of logic and state. So we have a price feed program that's deployed to, say, DevNet, for example, and that has its own program ID. But then each feed is its own account, right, which stores the data, the price data. So here are the accounts for DevNet for each Chainlink data feed. So now we've come to the third exercise. In this exercise, we're going to create a program with Anchor, and that program is going to basically look up some data from a Chainlink data feed, such as the price of Ethereum, the current price of Solana, and it's going to then basically just print that out on the program log and then store it in an account. And then in our client, we're going to read the value from that account. So I won't go through the entire exercise because a lot of it's similar to the steps in the previous one, but I just wanted to go through the code and maybe point out a few things. So I might just walk through the code first. So the first thing to note for this exercise is because we're interacting with a real Oracle network, this exercise is done on the DevNet network. We're not using our local cluster for this. So it's all done on DevNet. So we initialize a project. We set our config to the DevNet RPC address here. generating a new wallet address again. We're doing a double airdrop here because for our wallet, because deploying this takes up, I think, just over 2 Sol. So I'm going to go into my that was a bit too fast. That means it was running on my local net. So I'm going to set my config to DevNet. And if I do my airdrop again, does Chainlink provide data besides price feeds? At the moment on Solana, it's just price feeds and just crypto price feeds. However, that will probably change in the near future. So once that airdrop is done, yes, as you can see, this project is going to use the Chainlink Solana library here. So you're going to add it to your cargo.toml, and that will basically pull the Chainlink Solana crate so that we can use that to look up price feed data. So now the program itself is quite similar to other programs that we're looking at in today's exercises. We declare our program ID here, which we're going to change. So we have a struct here, an account struct called decimal. This is where the structure of the data that gets stored. So we store the price here in this value field. And we're going to, decimals just stores how many decimals the current price feed has. Because the price data is generally padded out to like 16 zeros or something. Then we've got a couple helper functions that are used just to kind of format the return price feed data. So instead of getting the price of Ethereum with a whole bunch of zeros at the end, we have a couple helper functions here written in Rust to just change that to be to look like a proper currency value and to strip out the zeros. So I won't bother going through the low-level implementation because it's just purely Rust things and it's not relevant to kind of what we're learning today. So here's our main program logic defined by the program tag. We have one function here called execute. No parameters, we have an execute context here. In the execute context, this is where we say all of the accounts that we're expecting. So the first thing we're expecting is a decimal count. This is the account that we're going to be storing the price data in. It's of type decimal, so that's this struct here. So it knows how to deserialize the data. We're taking an assigner. Sorry, it's called user, but this is the one signing the transactions. And then we're taking a couple Chainlink specific accounts here. So the first one of the two is the Chainlink feed, right? It's just an account. This is the feed from the Solana, the Chainlink docs to say which price feed do we want to look up the latest price of, right? So if it's Ethereum, we pass in that address. And then the next one is the Chainlink program. So like I said before, the Chainlink price feed smart contract, if you will, has been deployed to Solana DevNet. And this is just the program ID of that so that we can basically do functions like look up the latest price, right? So remember, there's a separation of state and logic. So this is the logic part, the smart contract part of the Chainlink price feeds that's been deployed. And we need to invoke that and call some functions and then pass in some accounts. And then, the last one is the system program. So that's it really. In the body of the function, you can see using this Chainlink library here that we defined up here, use Chainlink Solana as Chainlink. We're just doing 3 function calls from this Chainlink library really. We're calling latest round data, description, and decimals. And the one that we really care about is the latest round data actually, because that actually has the latest price. So once we do that, we literally say let decimal equals mutes account decimal context accounts dot decimal, which is the account here. And then we just basically store the value in the decimals, right? So round dot answer. So this has the latest price here. And then once that's stored, I think we print it out to the screen. And then that's it. So we're basically grabbing the latest price from the passed in price feed account here, and then we're storing it in the passed in account here, the decimal account, right? So that's the source code. And then on the client side, very similar to what we've been working with once again. So this is the deployed Chainlink program ID that has all of the logic, all of the functions such as latest round data, description, decimals, etc. So that's that. So that's just basically a static constant that doesn't change. We take in which Chainlink data feed we want to look up the latest price for as an argument on the command line via feed. Otherwise, I think it defaults to the Solana USD feed. And then in our main function, we just get a connection to the deployed program, which I just walked through. We generate a new key pair for our price feed account because once again, in our context, we're expecting an account to be passed in to store the price data. That's that decimal one here. And then we're doing program.rpc.function name, which is execute. And then we pass in all of the accounts. So the first one is the decimal account that's going to store the latest price data. Then our wallet address that's generating, signing this transaction. Then the Chainlink feed that we specified, we want to look up the price for, which we can take from here. And then that static constant, the program ID that contains all the logic for the Chainlink price feeds on Solana, and then the system program. So once that's done, we print out the logs once again. And then what we do is we read the state of that decimal account that we passed in. So that price feed account dot public key, we call account dot decimal because that's the name of the struct dot fetch, and then we say latest price dot value there. So yeah, there's a question in the chat. Is there a single Chainlink program on Solana with all of the feeds, or are there multiple programs? So there's one program that's deployed, and that's deployed at this address on DevNet. But that program, then there's a feed, there's an account for each feed, sorry. So when you call that program, functions in that program, you need to pass in basically one of these accounts. And that program, which looks up the latest price, etc., that basically uses each specific account, right? And yeah, so when you populate your cargo.toml, you put in the Chainlink Solana library here at the bottom under the anchor lang one. And then I think, yeah, that's it really. So I'll just run the, whoa, that's really big, hey. So once again, we need to set our anchor provider URL and anchor wallet environment variables before running our client. In this case, we're setting it to DevNet, and then we can run the client and it should hopefully look up. In my case, I think I'm looking up the price of Ethereum. That's the ETHUSD feed that I'm passing in. And as you can see, we have a whole bunch of output there. So price is 3491.23. Yeah. Yes, so the Chainlink program is responsible for keeping up the various feed accounts up to date with the latest prices. So this deployed Chainlink program is actually it's on our GitHub. I'll paste the link. So that program also has it's also got various functions for the oracles to call to push prices to the price feed and to get paid and things like that as well. So definitely check out the source code if you want, but basically that's what that is. It's just the logic for us to look up price data as well as for oracles to call functions to push price data and to collect payments and things like that. Cool. All right, I'll leave everyone to have a bit of a play. I'll try to go through some of the previous errors, and we will continue. What time is it? We'll continue. I think we have 40 minutes left, so we'll give everyone about 35 minutes, and then I'll wrap up the bootcamp in the last 5 minutes by talking about where you can go to learn more. But for those who finish early, if you could just hang around until the end, that would be great while I wrap it up. If you can't hang around, I'm just pasting now the survey link in the chat. Make sure you fill it out and put your email in there if you want a POPE. But I'll share that again at the end. But yeah, have a bit of a play, and we'll resume in 35 minutes and wrap up the bootcamp. So congratulations to those who were able to complete the exercise. Awesome work. Not only did you deploy and interact with another Solana program, you used Anchor framework once more, and you used Chainlink data feeds on Solana. So you got high quality price data in your Solana program. So now that's it for today's content. Let's wrap things up by talking about where you can go to learn more. Now there's some really cool links here that I'm going to be sharing in the chat. So first place here is the Solana Cookbook. This is a really awesome collection of tutorials and guides for programming with Solana. So I can highly recommend this if you're going to continue your Solana journey. I've looked at their serialization and deserialization tutorial probably dozens of times now. Really great resource. Next one, soldev.app. This is another really great collection of guides, tutorials, and references in a really cool blog type format that anyone can contribute to. So it's open source, so you can contribute your own content to here. So another really great place to go to get content on Solana development. There's also the Solana developer page on the official Solana website. So I'll paste that in the chat as well. Feel free to bookmark it. There's some really great developer resources here, tutorials, projects, other boot camps that you can watch on YouTube, and just a bunch of really great resources here as well. The Anchor book, this is the place to go for all things Anchor, other than their Discord. Really great place for getting reference information on Anchor. It goes through kind of each part of the Anchor framework one by one. It's even got example projects that you can play around with and build up. And yeah, just a really great resource for learning Anchor. In addition to this, moving to Chainlink, so we have what's called our Solana starter kit pinned to our repository in our GitHub, which I'll paste in the chat here. This is a pre-packaged repository for using Chainlink on Solana. It's pretty much exactly the same as what you created for your last exercise just now. However, it also has another client called Read Data, which does what I explained earlier, which is just reading data from a price feed account without generating any transactions. So if you want to play around with using Chainlink on Solana, you can have another look at this. In addition to this, our docs has all the information about using Chainlink on Solana as well. So you can go to docs.chain.link to go to our docs, and then you click on the Solana tab here, and then it has all the information about using Chainlink on Solana here, and kind of some of the instructions that we went through in the exercise. So in addition to this, I highly recommend checking out our blog at blog.chain.link. A lot of the content here is focused around EVM chains. However, there's a lot of great articles discussing fundamentals and technical details, such as, what is an oracle, data quality for DeFi smart contracts, what is Web3, why does crypto matter, and things like that. Next, Chainlink Hackathon. So we just kicked off our latest hackathon. Even if you're just starting out on your smart contract developer journey, definitely recommend signing up. I'll paste the link here. Whether you're going to build something on Solana or another chain, it doesn't matter. There's prizes for everyone, beginners and experts. They're really fun, great fun. There's a lot of awesome content, and there's team building exercises too. If you don't want to go solo, and just a really great experience. So highly recommend signing up and trying to create something by yourself or with others in the hackathon, whether it's a basic Solana project, an advanced Solana project, or a project on another chain. So yeah, can't recommend this highly enough. I actually got a job out of participating in these hackathons. So there you go. Now, if this bootcamp has inspired you to start building Solana smart contracts, we've got a really great blog post on our blog called 77 Smart Contract Use Cases Enabled by Chainlink, which gives you some really good inspiration around some awesome examples of smart contracts that you can build, right? And it covers quite a few categories such as DeFi, gaming, NFTs, metaverse, and all those types of things. So that's it really. We have now reached the end. If you are still going with exercises, that's fine. If you're still going to go on with exercises in the coming days, that's fine. We'll support you. The best place to get support is for the bootcamp anyway, going forward, is in our Chainlink Discord. We have a bootcamp channel here. You just need to verify yourself and then go into the rules and assign yourself a developer role or just any kind of developer role. If you can ask questions in the bootcamp, I'll monitor it over the coming days and weeks and try to help everyone. In addition to this, highly recommend getting yourself added to the Solana Discord here, and also the Anchor Discord here. I'll paste some links. Maybe Zach, you can paste some links in the chat for those. Yeah, and they're great resources. They're always well monitored and you get responses. So if you ask a question, people will generally respond after a while. So yeah, if you have issues, it might pay to ask in those places as well. Yeah, I'll paste a link in a minute. But other than that, just a quick summary on today. So today we talked about Anchor, we talked about writing and interacting with programs using Anchor, we talked about the Oracle problem in Chainlink, and we talked about Chainlink data feeds. So hopefully this bootcamp has given you a decent understanding of Solana, building Solana programs with Rust, and kind of using Chainlink on Solana as well. So congratulations guys, you got to the end. Awesome work. It was a lot of stuff to take in just like a 6-7 hour course. But for those who are able to just get a basic understanding of how to build smart contracts on Solana, how the program account model works, how Anchor works and how it kind of makes things a bit easier, and how Chainlink works on Solana. Awesome work guys. I hope you got something out of it, and we look forward to seeing all the cool things that you'll go on to build as part of the community now. So congratulations, you've completed the bootcamp, and we look forward to seeing you in the community. So yeah, once again, I'll leave this open for a little bit for those that are still going, and then after a bit we'll close it and we'll support people in the Discord channel. So feel free to reach out if you still have issues. Once again, please fill out the survey. I'll paste the link in the chat as well. If you want a poke to be sent out, make sure you fill that out and put your email in. In about a week's time, if you go to chain.link/bootcamp, you'll be able to access all of the materials, the recordings as well. They're going to be edited, but as well as the exercises again, the answers, the bonus answers, and things like that. But if you have specific asks like please send me slides for day one or whatever, if I don't answer you in the chat because there's a lot of chat going on, feel free to reach out to us either directly via email, via my email, or you can ping me in Discord in the Bootcamp channel, and I'll send things to you where I can. But yeah, thank you for everyone, and congratulations.